All right. And oh, I have I have my normal headphones. It's actually broken, but I'm like, whatever, I'm just gonna put this in. So if for some reason I do that whole mute thing again, I don't know, someone just like wave their hands or whatever. And like if I'm really keep going and everything like that. I'll keep the chat open too, just to kind of make sure that I can see what's going on, all that stuff. All right, but let me go ahead and start sharing my screen. And let's see here. So last time, okay, these past few days, right, we've been talking about getting stuff set up. Let's see here. Sorry, I'm just trying to talk and click at the same time, and I'm not good at that. There we go. Let me move you guys out of the way here. All right, so we were talking about different, what is my, sorry everyone, my window's doing weird stuff. All right, there we go. It was just showing my eyes and not the rest of you all. We were talking about basically getting ourselves set up. We've been doing Python. Wednesday, we were talking about NumPy and introducing the idea of this package. And so we did some basic stuff with NumPy. You guys all see my screen here with NumPy arrays, right? Okay, good. So we talked about NumPy arrays, which were a little bit different from lists. I think a lot of people, including myself, when I see arrays, I'm like, oh, this seems closer to like what I'd expect, what a list would do. So you'll see us use NumPy arrays a lot. So we talked about this, what they look like, how we can basically put or do different math with them. We talked about basically having essentially a nested list, right? Which is basically just a multi-dimensional array. So we can think of 1D arrays, 2D arrays, or matrices, right? 3D arrays, and we can even go further and further. You'll usually not call them arrays sometimes. You'll usually people say matrices and stuff like that, just kind of inheriting a lot of the mathematics that, reason why we talk about arrays and stuff. And then we even talked about how to use some of these built-in functions, like for example, producing, a certain shape of a matrix, right, with zeros and ones and all that good stuff. And then we also talked about slicing it and saying, how we can get specific parts of it. We even mentioned about reshaping, like we can reshape matrices and stuff like that into what we want. So some really basic stuff. Or this is the basics of NumPy and why we would start using this. We'll talk a little bit more today, but the reason why I wanted to mention the most about arrays is because we're going to start talking about pandas. And I'll notice how I say pandas, almost an emphasis. It's just pandas. Just in my head, I pronounce it slightly differently. But pandas will actually use this structure in the NumPy, and we'll see exactly where it comes from, but in the series and data frame structures that are in pandas. So let's kind of go into some new stuff. So let's see here. I'm going to skip over this part. I was going to have a little warm up, but since, I want to make sure we have enough time to go through the stuff we need to, we'll just dive right in. So we'll first talk about going from NumPy to Pandas. So we're going to introduce the Pandas library. Quick thumbs up. Who's already gotten to that section in topic 4? Pandas. All right, I see a couple of thumbs up. Looks like some people don't have their thumbs up. So that's okay. So, eventually you'll get into this part. But Pandas is basically a really useful library. I'll say library and package, just nothing interchangeable. And it's based around the NumPy package itself. And what's really nice is that if you understand NumPy really well, you'll probably understand Pandas really well. There's a lot of very similar structure. However, there are some very specific extra stuff that's in Pandas that's meant for data science and loading data and processing that. That's not in NumPy. So you'll see there's not exactly a one-to-one correspondence, but it's actually really useful. I'm kind of referenced back to this handbook again, the Python Data Science Handbook. It's online for free. Again, you guys all remember seeing this before, right? This little guy. Yeah. So note that you can buy the book. It's by Jake Vanderplas, another data scientist, and just has a really great information, for NumPy itself. I would really suggest if you're curious about NumPy, really reading this chapter. And then he talks a lot about Pandas. I would say is that if you were to read through this table right here, this is almost everything that we're going to talk about in phase 1 about Pandas. And if you understand this stuff, you basically will need pretty much everything you need to know for Pandas to actually use it and find it useful. And then of course you can always learn more stuff on top of it. Okay. So some objectives, right? So what's the point of this kind of section today? So this is going to take a little bit of time today, most of our time at study group. But our goal basically is to understand and explain what Pandas series and data frames are. So series and data frames, I want you to come out of this knowing what a series is and what a data frame is in Pandas. And note that how they differ from dictionaries and lists. You'll see that there's some similarities between the two, but kind of know that how these relate to and differ from dictionaries and lists. Okay. We're actually going to create series and data frames from dictionaries and lists. So we'll actually see how we can kind of create these things from these kind of data structures, and then actually perform data manipulation on the series and data frames using methods and attributes. So what's nice about series and data frames, there are certain like methods and functions that we can apply on them that can be really useful when we're handling data. And then actually doing some more data manipulation on these series and data frames using Lambda functions. So we talked about Lambda functions, using regular functions like def functions, right? So not Lambda functions. And then also applying these attributes called .map, .apply, .apply map. So those three sets of methods are really, really common in Pandas because they can be quite efficient in the right circumstance. So we'll see what this goes through. Okay, so we already saw how to import NumPy before, right? So I import NumPy as NP. You know that NP is kind of just like a nice shortcut that generally accepted. And then Pandas, same idea, is that we can import that as PD. Okay, so import it up. Ooh, real exciting, right? So we got one. So the first thing is like, what are a series and what are data frames? So one really cool thing about like Pandas is that it has these structures, data frames and series, and really are just NumPy arrays, and they're structured very similar to a spreadsheet. So kind of thumbs up who's like used Excel before, either, you know, their personal life, just making their fun Excel sheets for fun, or, you know, at work. All right, cool. If you're familiar with Google Sheets, kind of the same idea, right? So these spreadsheets. And so if you're used to using Excel sheets, spreadsheets, right, from work standpoint, you'll see the similarities within Pandas. But just know that we have a lot more flexibility than we would have in a typical spreadsheet. So the one thing I would connect this like series versus a data frame. A series is a one-dimensional array. Think of it like a column of data, right? So if you imagine that your spreadsheet usually would have like, you know, like your headers, right? And then each row would be a line, like a single data point, and each column would be kind of like, you know, let's say you have like a list of passengers on like a train. You might have something like oh, like what's their first name, what's their last name, you know, what's their age, right? Something like that. And each column then would be like a series. So that's the way you can kind of think of this series. And then data frames. Data frames really just two-dimensional array, which think of it just like the whole spreadsheet itself. So that's really what a data frame is. And we'll usually be interacting a lot with data frames. And then usually we'll take segments out, the series, the columns, and operate on those single columns at a time. Okay. So this might make a little more sense if we see some examples. So this right here, I'm actually going to create a series. So note that I'm just calling a variable equal PD, right? Pandas dot series. And so this dot series, basically this kind of method will actually create a series for us. And you can see I just have a list of data right here. So just a list of numbers. And you can see here, if I actually print this out, remember that Jupyter Notebook is actually using display. So it's going to display data call. You can see here is that we have the data 0.2, 0.4, and so on. And note that it has a D type float 64. So if you remember, NumPy has inherent to a little bit of stuff from C where we're actually very specific about what kind of data we put in there. So you can actually see that there's a little bit of, it has like saying all of this column, all these values in the series is a float 64. And note that the 64 basically is just saying 64 bits. And note, well, later on, you can look in the documentation to actually change this type if you want. Also note that there's this 0, 1, 2, 3, 4. That's just basically this index, right? So it's basically referencing like what part in the series. So you can imagine a column, right, of data in an Excel sheet and saying like what row that is on. Okay, make sense, everyone? Cool. One thing I'll just note, because I might not show it later on, is that if I change this, like let's say if I make this into a string like this is perfectly fine for a list. But if you remember in NumPy, you can't have a mixed bag of types. You have to have only one type, right? So if I do this, the series will actually work perfectly fine. But what it'll do, it'll define this whole column as a different type. So it won't be float 64 anymore. Instead, in this version at least, it calls it object. Note that this in the learn environment, I believe we're using a Pandas version that is, it's not the newest version. So the newest version, which is still not used widely right now, which is why we're using the previous version, this can actually show up as string instead of object. But basically just know there's a slight difference in here in how it reads in the data. Okay. Make sense? Cool. All right. Cool. So you can see here, we actually can write here the PD series in the same exact data, but note that I can give a different index. So remember this index was 0, 1, 2, 3, 4. That was automatic. If I run this guy right here, it actually uses the indexes A, B, C, D, E. So it actually allows me to reference those kind of letters. This isn't, to be quite honest, isn't very common that you would do for a lot of big data stuff, but it can be useful if you want to have a certain index reference. So you can kind of see what that looks like. Note that I'm just going to make another copy here of a different data set. So this is data call, this is data call other. And you can see here, basically just slightly different data. And what I can do now is I can actually create a data frame from our series. So this data call right here, this pd.dataframe is going to create a data frame that's from this data column. And we can see here, it's kind of a nice little, you can see it's a little bit nicer here. Jupyter Notebook tries to display this really cleanly. And you can see that data is still the same stuff as this stuff right here, right? You can see there's our index, right? And we can see these are our values in here. Note that we didn't give it a column name, so it just defaults it to be column 0, right? So note that we can also put in multiple series, right? So you'll see data call other. And in this case, instead of calling just like the actual series itself, I actually have a dictionary, right? And so we have a key, and there's the value, key and the value. And you can kind of see already what's going to happen here. This is going to be called the first call, right? And then one's going to be the second call. And then it's going to have data from each one of these parts. So if you look at this now, you can see the data frame looks like this, where we have data from that first column and data in that second column. Yeah. Sound pretty good? Yeah. Any questions at all?
Is the index was indented? Does it have to be? Is that just the way a couple up you had the index where you listed the index?
Oh, right here.
Yeah.
Oh yeah, no, that's not necessary. So I'll show you just real quickly. Like if you wrote this in one line, like this is completely valid Python. Python does allow you to have like indented as long as it's wrapped around in a parentheses. Okay. So you can see here is that like I have this parentheses around like that, and it just makes it a little bit easier to read. So you'll see this very commonly.
I thought maybe we had indexed or tabbed it in or something.
Yeah, no, thank you for pointing that out. That's, if you haven't seen that before, it might be kind of weird. Note that this would also work if I had something like this. Like, I mean, it doesn't really matter too much. Like I could have it weird looking like this, but it's because it kind of wraps around this parentheses and this parentheses. Okay, cool. Yeah, and that'll happen a lot when you have a lot of different parameters. So, and it's a style thing. Okay, cool. So again, we got some really cool stuff. So now we can say, okay, like what do we do if we try to break some stuff? See if we can try to do some different things. So let's say I have a data column of this series right here, and note that I just called the index ABC, but then ZY instead of ABCDE, right? And I have the second column, right? I guess technically that was the first column I used. I'll just call it ABCDE. So before I do this, you can see that there's some indexes, right, that relate to each other, and you can see that's kind of what happened here, right? See the index kind of relating back to here. What do you think is going to happen if I try to combine this series and this series, but they have different indexes for the last two? What will our data frame look like?
Probably have A, B, C, D, E, Z, Y, maybe blank spaces.
Yeah, good. So
go ahead.
No, go ahead, Safe.
Yeah, for me, I'm just thinking that they might, if there's conflicting ones, they might just have them both with a comma. But yeah, that would just be a guess.
So I think, both guesses kind of like, it'll still list the index, but, might do something with like the ones that are like, don't have that index in that series. And you all are exactly right. You can see here in this case, Clark said like blank, but in this case, to be more explicit, Pandas actually says it's a NaN type, because basically saying like, oh, it's not a number. It doesn't exist here. So note, depending on what kind of data type this is, for example, if I put this as like, remember how this was now create a float, or not a float, this will create a string, stuff like that. You might have something slightly different. You can see it changes. Well, actually, no, I'm sorry, this is a different version, so never mind. But you can see here is that it's just going to say, okay, it's not a number, meaning like it's missing. So like a missing data is not a number. Cool.
So the series, the data in the series has to the same data type, right?
You're saying the series in the data frame? Or...
Inside the series, like let's say.
Yes. All this will have to be the same data type. And if it's not the same data type, Pandas will be smart enough to try to make it the same data type. But note that can cause extra issues because, for example, I'll give you a common example. Let's say you have a bunch of numbers and you look at it, it's like, oh, it looks like a bunch of numbers. And then you import it through and one of the data points was a question mark. Well, that's not a number, right? So it's going to convert the whole column instead of numbers, it's going to convert it into like an object in this case. So that's a really common thing to do. And we'll see a little bit like what we can kind of explore in here when we explore the data of a data frame. Okay, cool. Sound pretty good? All right, so let's do a quick knowledge check, right? Why would you use a Pandas series and data frames instead of built-in Python data types and lists and dictionaries? So you don't have to really think about like what the exact answer is, but you can probably think about like, you know, how like, for example, like just looking at this, I think it's a lot cleaner than thinking like if I wrote this as a dictionary, like a dictionary of lists, it'd be a little bit harder to kind of parse through thinking about like what do I grab. But note that we're going to basically reference it similar to how we would have like a dictionary of lists. Okay. So cool. So here, just have a little built-in answer, right? Or a little quick answer. It's like, oh, we can use built-in methods. So we're going to see a little bit of like how we can actually use these methods to process this data that we normally couldn't use on a dictionary or a list because we know what the structure is supposed to look like. Okay.
I had a question.
Oh,
like
yeah,
it's kind of the opposite of the question that was asked. Like
Mhm.
just looking at how powerful series and like arrays, series and data frames are. Like I'm just wondering like why you would use lists or dictionaries.
Yeah, so that's a good point. So you're just like, oh, like, you know, we're using Numpy arrays and, you know, Victor loves Numpy arrays. Like, well, why would we even bother lists and dictionaries? The biggest thing is that flexibility, is that Numpy arrays in particular are able to do things like we'll see later on, possibly like different, like we'll have better efficiency on certain like processing and stuff like this. But the thing that you give up on it is the flexibility to have whatever you want. A list and a dictionary, you have a lot more flexibility with only very few limitations in what you can do.
Okay.
Yeah, so that's the main reason. But the trade-off for that flexibility is basically speed and efficiency. Like essentially, Python has to do some extra thinking when it handles a list in a dictionary because it doesn't know what the type is. NumPy already knows, like at the very beginning, oh, I know what type this is, so it can just assume this will all be the same type. Yeah. Does that make sense, Safe? Cool, thank you. All right, cool. So let's move on then. So let's see a little bit of some things we can do. And these are some very common methods for importing and exporting data. So this one right here, pd.readCSV is probably like the one that you're going to see the most common. You're probably the one that you're going to use the most. And as you might be able to guess, it's going to read in a CSV, a .csv. Note that CSV stands for comma separated values. And basically you can think of it like, essentially it's a way to put a spreadsheet format in a file. And it's actually a very simple file. And so a lot of data is actually transferred through CSVs. But note that, you know, for example, if you have like an Excel data sheet, right? Like, so it's like, let's say you're working with a company or a client and they only really use Excel. And you mention CSV and they give you a weird look, like, well, I don't know what you're talking about. But you know they have spreadsheets and like how they form stuff. You can actually take that .excel, that Excel format and actually read it directly with Pandas. So for the record, I don't know if anyone knows this about Excel files. Excel files are actually just a zipped form of CSV. So there's actually a CSV file in there. And there's actually a zipped form of it. So you can actually, for the record, if you ever get an Excel file, you can actually name it to .zip, and then uncompress it, and then get all the good stuff inside of it, which is kind of fun. But Pandas can then read it. And then later on, we'll talk about JSON. We'll talk about that, let's see here, not next week, but the week after, we'll talk about JSON format. So that's JavaScript object notation. And basically, this is very common, especially, I would say the web, but also just it's been common overall of like passing information from one system to another. And so you might come across JSON. Note that this is CSV is a very structured data where we basically have rows and columns. JSON doesn't necessarily have to be that structure. So you might actually, you know, you can get a data frame from a JSON object, but it's not going to be, it might not be exactly what you want. And then you can see here pd.dataframe from dictionary. So note that you can get something from a dictionary, but you have to add this .dataframe right here. And you can see this is kind of like to read in data to get a data frame. This is kind of like to take data and output from a data frame and output it into a different format. So in this case, we can export it to a .csv or to an Excel file or to a JSON file or to even a dictionary in Python. Okay. Does that make sense to people? Like what these are going on? I didn't show you how they're used, but hopefully you guys can conceptually understand how this is going to be used. Okay. Cool. All right. So next thing we want to talk about is like def functions versus lambda functions. So I showed you guys lambda functions a while ago, right? About like how lambda functions work, and basically they're just functions. We'll see like why lambda functions are really useful. And in particular, they're really useful for these three methods: .map, .apply, .apply map. And what you can do is basically use these methods on data frames and series, and basically say, hey, let's go ahead and like say, I want to change every value in this column using this function, right? So we might sometimes have a function already built that say, oh, do this thing. But sometimes you just want a really quick thing that you can do. For example, like remove all spaces, or multiply it by 5 or whatever, or something along those lines. And you can use Lambda basically to write that really quickly in line versus like having to write it somewhere else and then reference it down here, which the further away your code is separated from each other, the more likely you'll have an error or make a mistake at some point. Okay, so I'll just put this in here, and note that I have a couple resources that are in the talk about like why .map, .apply. Just note that these can be more efficient and faster, but not always. So there's some use cases why that would happen. Okay. Cool. So I'm going to give you guys some more information about like how to write these things. Methods in formatting clean data. We can do things, for example, I mentioned like, you can change the type of the actual of the column. So remember how I said each series is like defined like what type it is. You can actually try to force the type as saying like, oh, change it as this type. Kind of like when you do like, if you have an integer but you want to convert it to a float in Python, we do float, with our braces, and then the actual variable, convert it over to a float, right? So that's kind of the idea with that as type, but it'll change it for the whole series. Okay. And then we can do things like toDateTime, which we'll see a lot is really useful for time series data. df.rename, that's basically just going to rename certain columns and stuff like this. df.drop, that's very common, where we will actually drop out a column or data. Basically say, oh, like this is unneeded, or maybe it's repeated data, we'll actually drop that out. And then df.setIndex, this can be useful sometimes. It's not used every time, but you can do something where you can reset the index and do other things with it. Just note that these guys right here, basically you are changing data, but in general, we have a difference between in place and out of place. And in general, that it's a good practice to preview changes before overwriting the data. So what you'll generally do is actually say, instead of saying df.column as type, it's not going to actually change the type of the data frame itself. It's just going to return a copy with a new change. And a good idea is to save that copy, look at that, say, oh, does this look good? And then say, okay, looks good, let me overwrite it, or even just like continue on with this new copy. So you'll see kind of this difference. And don't worry about if you're like, well, how does that work exactly? You'll see it and you'll see what I'm talking about. But just know if you see something called in place basically will completely overwrite whatever you have. But when you're data processing or processing the data, it's kind of a good strategy not to just overwrite what you had. You could technically then restart and reload the whole thing, but sometimes if your data is really, really big, you can imagine that sometimes that like rewriting it and oh shoot, I got to go back. There's no way to go back other than restarting the whole thing. So just kind of a quick note to have there. Okay. All right. So I believe now we can actually start using some stuff. Now I showed you a whole bunch of different methods and stuff. Let's actually like do some code, right? So note that I'm going to be importing this data set called load wine, or not load wine, it's wine data. Like basically data about wine. This is from the sklearn library. So note that I kind of mentioned about import pandas as PD, but right here, I'm basically saying from this package right here, don't worry about, we'll see this more, but we're basically from this package, import this method right here, or say this function. So this basically will allow me to do something in this method, or this function will actually load the data set as a data frame, if I remember this right. So maybe it's not a data frame. We'll see what it's actually, let's check it out. So I'm going to import these two together, including pandas. We already did that, so we'll work fine. And then we'll say data is equal to load wine. So if I run this right here, it'll take a second and you can see it's all done. And let's just see what data is. So if I do data, you'll see here, it's like, oh, it's a dictionary. In fact, if I do type dictionary or data, you can see here, it's actually a bunch right here, but you can see it's basically a dictionary. right? So we can see, oh, there's a dictionary data, and this is the key, right? And this is the whole value, which you can see this dot, dot, dot. Jupyter's just being nice for us. We don't have to like see all the data all at once. We can see, oh, this is a bunch of data, which is basically a bunch of Numpy arrays, right? Right. And then we can see there's also, in this case, target, and you can see here there's a Numpy array, a bunch of values, and you can see a bunch of other information, for example, the description and all that good stuff. So this is just built from what's returned from this load wine data. Okay. So we can take this stuff, and what I want is I really want to make a data frame from the actual data itself, right? So the data, and then I want the column names too, right? And it turns out we can actually look at, let's see here, not F names, where is it? Feature names. Feature names is actually, the features are usually, if we talk about how the columns themselves. So it turns out like, oh, we can get the actual column names. Otherwise, it would just be like column 0, column 1, column 2, and I don't know what the values represent. So that's what we're doing this right here. So say df equals pd.dataframe, and then we're doing data. Remember, data was the variable, and this dot data basically is just referencing saying get the data key, and then columns. There's a little parameter here. Columns is equal to data, the variable, dot feature names, which is just the key, right, for all the feature names. Okay, and just to show you a little bit what that looks like, I'll do we'll just do df, and you can see here. I have each of these column names down, and then each data point. And so note that like each row here represents one wine, one data point, right? And these are all the attributes, the features of that single data point. So this wine has an alcohol percentage of 14.23, malic acid of 1.71, and so on, right? So you can see all of these different things.
Victor?
Yes.
It is feature names, is that particular to just this data set you downloaded, or is, if we were to type that for something else, we need to scan the data to find out what the names of the columns are?
Yeah, good question. It would be specific to this, the way this is outputted.
Okay.
It turns out sklearn, which is what this package is going to in their data sets, generally use the same terminology,
Okay.
but it would have to be dependent on what data set you actually loaded and like how it's structured. Good question. Yeah, these are specific to this data set, which I loaded in as data.
Okay.
Is it kind of like Project Gutenberg, where, you know, you always have like that similar type of header and footer, but for the like everything that matters is like different in the middle?
Yeah, it's much more. You're saying like just the fact that we have feature names and data, and then you can see here there's a description, right? DSCR, right?
Yeah, it's like
this is, yeah, it's kind of like a style guide for sklearn, but this is very, very likely if you came across another set of data, it would not be formatted in this form. And so you have to know a little bit. Like I kind of did pull a fast one on you guys. I already know what loadwine does, and if you really wanted to, you could do like, you can see help. Let's just do. Oops. Can't type today. There we go. Nope. This is why. There we go. So you can see here, here's the doc string and tells you a little bit of like what this does. And this turns out to be specific to sklearn that says like, oh, okay, they format the data in this way. And these are just basically little play data sets for you to kind of mess around and kind of check out new, like the reason why it's built this way is usually to try out new algorithms and new strategies and methods and stuff like this. But you can see it gives extra information even more about like what's going on. So really what you have to know is really what this guy is going to give out first. Yeah. Cool. Yeah, good. I'm glad you guys pointed out, because that might not be very obvious when I just type this out right here. It might seem like, oh, everything has dot feature names, but it's not. All right, cool. Any other questions about what I just did or looking at this data set? Or this is data frame. Cool. Note that it does this, like, you can see there's 0 through 177 and there's 178 rows. Note that this index, it happens to be 0 all the way to 177. Not every data frame will actually be sequential, and there might be missing gaps and stuff like that. So it's sometimes good to look at saying how many records there are. We'll show a little bit like what we can do to explore the data. And Sam R, you had a question.
So when you do data.data, what exactly is that doing again? I apologize. I heard you say I didn't process it well.
Yeah, maybe this helps a little bit if I actually do, if I do data, right, you can see it's just this whole thing, right? If I do data.data, it's actually going to pull out this guy right here. So if I do data, you'll see it's this thing right here. Makes sense. And all I'm doing basically, if I was being like really like careful, I could call this like, you know, like my data to load, right? And I just call it a variable and then just replace that with like this guy. And that'll do the same thing. Does that make sense?
I think the dot data is just a key to the dictionary.
Exactly. Yeah. And I kind of should say it's not technically a dictionary. I don't. Here, let's try it out real quick. Because if I look at data, this type, note that it's not a dictionary type. It's actually something built in sklearn. It's called a bunch. And note that basically it's like a dictionary. But let's see if I can actually do this. Because in a dictionary, you usually can do this, right? With the key.
Mm-hmm.
And you can see I can reference it the same way. So, but if I had a real dictionary, just kind of, it's kind of important to point out this stuff early on. That way you guys know. Oops. Let's just call it a quick dictionary, A1. Just one value in my dictionary, right? If I did something like my dict A, you can see it gives out 1, but could I do dot A? No, it doesn't like that, right? So like this is basically a nice convenient way. If some people who've seen other programming languages, you'll see people who can reference this like as a property. That's essentially what's going on here. But you can reference it either way in this case, just because it's a bunch type, which is kind of like a dictionary. Does that make sense to people? Cool. All right. Good questions, by the way, everyone. And it's good to call these out first, like early on, like versus me, like, you know, later on, I forget like what you guys know and don't know. So I'm glad you guys are asking that. Any other questions? No, free to move on then. Cool. All right. So like I said, like we have our data frame right here. We have about 178 different items. There's 13 columns, meaning there's 13 different properties. Note that, you know, I'm not seeing the whole data frame, but I'm getting an idea of like a little bit what these values are and stuff. Note that I'm not seeing what type they are. I can assume that these are numbers, but it might be the case that maybe there's like a question mark somewhere in here and you have to go check that out. So just know that we're just not done inspecting this, but this is a good first start. So it's like, okay, how do we inspect it, right? So some things we can do is .info, which gives us a feel for what the data are about. I'll kind of show you a little bit what that is. .describe, which is really nice. It tells you some descriptive statistics of numerical columns. So it'll take like numerical columns and tell you a little bit of the statistics on there, which is kind of nice because you don't have to go like take the column and like say, oh, calculate the average, calculate the median, calculate the standard deviation. And then we also have .head and .tail, where basically we can say, oh, just give me the first few records or the last few records. And that way I don't have to look at the whole thing. Okay, so let's check this out. So df.info, remember this is the actual, oops, sorry, I'm kind of scrolling around a little bit. Remember this is the actual data itself, the data frame. df.info actually just tells us about this data frame. So it's like, hey, there's 178 entries, 0 to 177 is the index. Data columns, there's a total of 13 columns. And then it tells me each of these columns saying which columns 0 all the way through 12. And this is called alcohol, malic acid, and so on. And you can see here it's 178 non-null. So that means there's nothing missing from here, right? Because we have 178 entries and 178 are non-null. Null basically means like empty, like it's not there, right? As we saw before. And we can see the D type. In this case, they're all float 64. Note that if there was some difference in here, you would actually see, you know, a different D type here, different data type. And you might have missing data, for example, you might actually see that this is missing here. So usually like I like to do is like I load my data frame and then do df.info and just kind of see what's in my data frame here, like what's going on. And this is a really quick way to look at it. And you can also see, this can be important when you have very large data. You can see how much memory usage. And it's like 18 kilobytes, which is very, very small. So we don't have to worry about that too much. Okay, cool. Makes sense right here, the df.info. Yeah, all right. Let's try df.describe. So what does that do? So like I said, it gives us some calculated statistics. So each column then is taking each column as like a single entity and doing some statistics on it. So in this case, it's showing like how many are in there. Note that this count is going to count only the ones that are there. So if there's only like 100 records and some of them are missing, it only show like 100 records here. Okay, it shows us the mean, right? Our average, our standard deviation, our minimum, right? So what's the smallest value? And then basically goes into different quartiles, if you guys are familiar. Basically the first 25%, the 50%. So this is basically the median right here, and then 75%. And then we see the maximum value. Okay, so this is a really quick way to get an idea of what's going on in your data set versus like looking at all the data once, like an Excel sheet or something. You can actually look at this very quickly, and it's pretty quick actually calculating this stuff out. And you can see it's done for every column. Note that this is only done for numerical columns. If I had something like a bunch of like words in my data set, it just would skip over it. It would just say, oh, okay, that's not a numeric value, so I'm just going to skip over. Make sense? Cool. All right. Move on to the next part. I mentioned df.head. So df.head will by default actually only show out the first 5 values. And this can be useful just to, like, if you have a data frame on a CSV and you load it in, and you're like, what's in it? Like, you can just load the first, few values and kind of just get a feel for what's in this data set. If you want to go a little bit more, you can actually specify a specific number. So df.head 10, I can look at the first 10 records instead of the first 5. Okay. And then df.tail is the opposite, right? It's kind of like you can look at the last few records, in this case, the last 5 records. If I put 10 here, you can see the last 10 records. Okay, and you can see about the index.
Can you specify the range within the head method?
Specify the which one?
The range of columns, let's say 20 to 50 columns.
Ooh, good question. So if you don't know, right, look it up, right? And so you can actually see a little bit. And this turns out, no. It's really a really basic command, just showing the first n rows. There's no way to specify, at least with this function by itself, what columns. Later on, you can do certain things like calling specific, like slicing the data frame and only looking at these specific parts. But we'll talk about that maybe in the future. All right, so I'll keep going through. We have some attributes of the data frame. So these aren't methods or functions. These are just like the things that are on the data frame in series. So you can see this .index, .columns, .dtypes, .shape. You notice this .shape is coming from like Numpy, right? And we talked about dtype right here. Note that we also can do .lock and .ilock, which Simon had just mentioned, say, oh, could we just get like certain columns? This would be actually really useful to actually select certain columns either by the name of the columns or by like what index they exist at. So we'll see a little bit of that too. Okay, I don't think I'm going to go through too much in here, but let me just show you a little bit. Like if I do df.index, you can see here we actually have the index here, and I can actually create a list. If I want, like, you normally want to do it this way, you probably would like iterate over it, but just to show you a little bit, like there's a list in here. The reason why it doesn't convert it to a list first, like we actually have just df.index, and you can see like oh, what's this right here? It basically is just a shorter way for Python to know. It's something called a generator, so it doesn't have to like load everything in memory. Because imagine if you have 1 million records and you just want to know there's 1 million records, like you wouldn't want to load 1 million records all at once. You might iterate over 1 million records, but not load it all at once. That's why it's represented this way. Okay. Note I do df.shape, we should get 178.13 because there's 178 rows, right? Which include like all the data points, and then 13 different columns. Okay. Makes sense. Cool. Going back a little bit, I can do .lock. So this one's a little funky sometimes. So I can do .lock. I never do it this way, so I want to get a little thrown off. Let's try alcohol. Oops. Sorry, I always get thrown off on this because I always do something slightly different from me. Did I spell that right? Alcohol. All right, so this is one like those ones like, hey, I can't remember what it does, right? Ask the documentation, right? So we can always go through here and say, okay, like how does this work? So it access a group of access a group of rows and columns by labels and such. Let's see here, a list or array of these. So it looks like I'm doing that right here. So sometimes they have little examples. Oh, look at this. They have a little data frame right here. I can check that out and say, okay, let me just do df.lock. It's like, oh, that's actually referencing the index. Like, oh, I don't want that. I actually want to I want to know by the column, right? So, okay, how can I do the column? And so, okay, like, how can I do that? Oh, there we go. No, is that right? Max shield. Oh, shield. Sorry. So you can see a single label or column. And then, so I never do it this way. Oh, all right. I'm going to skip over this part because I realize I haven't shown you guys all of that part. But, well, okay, tell you what. Let's just do a df.lock. This is the row. And then the column is alcohol. Fine. Trying to think if I did this wrong. All right, I'm going to skip over this for now because Victor doesn't use that lock as often. And you can see a little bit too, right? You're like, oh, like, you know, kind of skipped over that part. And normally I would kind of look into like, oh, what am I really on? I normally would use the iLock, which kind of reference like what position that is, because to me that makes more sense in my head. But sometimes you're going to hit things like, oh, I can't remember this thing, and you have to go look it up, Google it. But since we have a limited amount of time and I want to make sure to spend enough time for show you guys stuff, I'm going to skip over that for now. Okay. So some extra resources, just to talk about methods versus attributes. Sometimes that can kind of play a little weird in people's heads. Just know that methods are really kind of like functions that are attached to like the data frame, the series. If you're familiar with object-oriented programming, it's tied to the actual object. And then the attributes are kind of like things that are kind of inherent to that, you know, data frame or series. So these, for example, are actually attributes versus the methods are kind of like essentially functions that are tied with the data frame. Okay, does that make sense to people in general? There's some resources if you really get confused on that. Okay, so this is some fun stuff with masking. This is when we actually start selecting data and stuff like this. So this is normally how I would use like, you know, lock and .ilock and stuff like this, is that I can say, okay, what this is doing right here. So I'm going to show you a little bit what this does by itself. Is that, remember we have the data frame, right? And let's just do data frame alcohol. We can see that's actually a series. Moving forward, right? We can see that's a series. I was like, well, what if I just want the ones that are less than 12%, right? So I can do less than 12. And you're like, okay, this seemed like valid enough Python. What happens? Ooh, like that's weird, right? So I can see here, let me just turn this off right here so I don't have to. There we go. Okay. We can say, okay, only grab less than 12. And you see I get a bunch of true and false statements. Like, oh, well, that's not really wanted. I want to know which ones are less than 12. This is what we call like a mask. So basically it's just giving me a set of true and false values. And what's kind of cool is I can actually feed this into the data frame with .lock and actually say, hey, like only grab me the records based on this statement right here, this mask. In this case, what values in alcohol are less than 12. So if I do this right now, you see that it actually skips over. If you look at this, like, oh, nothing looks different. But you look at these numbers here, it actually, the first, you know, few records are actually skipped over because they're more than 12, right? And you can see here, I'm actually getting only certain records. In fact, you see a little skip around. And you can see all these values under alcohol should all be less than 12. And sure enough, there's only like about like, I don't know, about 15, 20 of them that are less than 12. So this is a really great way to kind of get these values. And note that I'm not looking at just alcohol now. I'm saying, hey, get the whole data frame, but only show me records that have that series is less than 12. Does that make sense to people? Okay. So kind of break this down a little bit more. And I like actually writing it like this because I think sometimes this feels a very like, I look at this and I'm like, oh, like what's in here? And I have to look for the extra parentheses. I personally like to write this thing as a mask and say, okay, here's the mask itself. And then here's my new DF. So my new data frame, and I can play around with it and getting just those ones with that mask. In this case, DF mask, okay? And you can see here, I now have this new data frame, new DF, and I can do whatever I want with it. This is kind of the idea of like, instead of having like, I could have done DF equals DF, but then I would lose all those records and I have to go back to reload the data and all that stuff. So that's why I'm calling it new DF. Okay. Does that make sense to people? Okay, cool. All right. I can also do things like multiple conditions. So in this case, I have less than 12, and I want alcohol that is greater than 11.7. So note that you do have to put these in parentheses. Otherwise, it's going to try to combine it all together. But I can basically have two conditions here. And note that this mask, again, just to kind of show you, all this mask is basically a series with true and false, right? You only see false here because basically most of the records are false. But you would see in some cases, if it was like some other value, this would be true and then some would be false. And it was only going to return now the true values. That makes sense, people? Okay. So now if I do this guy here, multiple, 2 different attributes, I will only get ones that are, you can see this is a smaller list now. I basically got everything that's less than 12, but greater than 11.7. So I kind of have it wrapped around that. All right. Cool. And note that this guy right here is a little bit different from Python. Instead of using like normal Python, we use and, right? Note that I have the ampersand here. So there's a subtle difference. And that's because specifically of how we're operating. There's a few reasons why, but main thing is because it's using this is a series right here. Like if I look at just this guy right here and look at like, let me just add a new cell so I don't want to overwrite anything. If I do type, you can see it's actually a series. And if I put and here, I think that'll give me an error. Yeah, you can see here, you can't do like, it doesn't like doing and because it means something else. So it uses this ampersand sign to say, oh, this series and this series combined together. Okay, cool. So other thing we can do is also the or. So note that or is done with this little, we call it a pipe. So on your keyboard, usually above the enter key, right? And that basically is showing like saying, is it less than 12 or is it greater than 14? So maybe I'm looking for just low alcohol and very high alcohol. So high relative, right? And you can see now I have different records. For example, I get these first few records 0, 3, 5, 6, 7, 8, right? And you can see all the different records now I get because these are greater than 14. Okay, cool. Yeah, any questions about anything I've shown so far?
Yeah, quick question. Can you use the literal and or keywords in place of that, or like what's the difference between that and the
Yeah, no, good question. So for what we were trying to do, you can't just replace and or. So like I have this little pipe here, you can't use or. If I do this, you can get a little hint of like what's going on. If I run this, because oh, there's an error, is that basically it's that this, remember how we talked about Python having truthiness, right? Since this is written in Python, this right here, it doesn't know what the truth, it's looking for the truth value of this series. It's like, is this series true or false? And it's like, in a lot of ways, you can kind of think there's not really too many situations where it makes sense to say this whole series is a true thing or a false thing. So that's why it's giving me this, basically it's like, oh, like, hey, like there's some weird thing called value error saying like this series is ambiguous. I don't know if this is a true or false statement. And that's really what this is looking for. And really, we're not looking for true and false statements. We're just saying, hey, what's true in here? Like essentially we're saying like, is this true? Like without the data frame. And then we also want this stuff too. I don't know if that kind of makes sense, but it's a slightly different question. Okay, cool. Yeah, and that's why we can't do it. No, if I do or here, same thing happens. This is going to be ambiguous. It's saying like, I don't know what the truth value is of a series. So yeah. Okay, cool. All right. Yeah. All right. Any other questions? All right, cool. Yeah. So note that's kind of like where the processing through, like how to process some data. Note those similarities to NumPy. You can kind of see, like now that we've seen NumPy, we can actually see what's going on here. Oh, good. Some people have messaged where you can find the file. Oh, and then Sam asked the same question of and sign. Can you use the and? Oh, just real quick. Someone said, can you use the ampersand sign instead of and in Python? So we might want to do like true and false, which will be false, right? Can I do this? And technically, yes, but there's some weirdness to it. So let me just show you like 1 and let's say 10. Let's try 9. Okay, 1 and 9. Is 1 and 9, would this evaluate if I put and here? Would that be true or false? It's 9. You're like, what? And this is where it's very confused. Like, he's like, what's going on here? This is how Python's treating different truth values and stuff like this. So it can be kind of confusing. But I think if I do and here, you get this 1 here. You're like, what's going on? And in short, this ampersand sign is basically doing bitwise comparisons. It's basically looking at how this is represented in binary and why we do, like, that's essentially what's going on here. So this actually ends up translating to 1. So in short, you can't just simply replace this ampersand and with the same thing. Sometimes you can get the same answer, just by out of pure coincidence, but it's not something you just like, oh, I can just replace these with two. They mean different things. Okay, good question, by the way. And then, okay, where can you find this file? So like I have this guy right here. I should have shown you guys that to begin with. Note that all the stuff right here is in Flatiron Curriculum Data Science Resources, right? And this is specifically in the NumPy section, or not NumPy, sorry. Let me just double check I got this right. It's on the data science basics. So if I go to, let's say the resources, data science basics, Pandas, then you can see here from NumPy. If you're ever like not sure, but you know the name of the file itself, for the record, like in like a GitHub repo, including this one, just trying to highlight that. There we go. I can actually search for this guy right here, and I can search for this in this repository and can see where that occurs and actually check that out. Why didn't that show up though? It should show up. No. Oh, because I'm looking for the. Okay, I just realized that wouldn't work because you're looking at the. It's actually looking for the code, not for the actual files. So just know that this one, I'll share it in the link right now. Here we go. I'll share this in the chat. And so what I'll eventually have is that in the branch full time on this README, I'll actually have the list of the stuff that we talked about. So this way you can find it that way. Okay, cool. Cool. All right. So sound pretty good. I mean, we showed a whole bunch of stuff with Pandas, going through. And even then, we didn't even go through all the different little options and stuff that we have. But I think at this point, you could at least get like the idea of like exploring that data and it loading in the data frame. So just know the big thing of data frame, I would say like df.info and df.describe are like almost every single time I load data, like I do those two commands just to see a little bit like what this data is and then get a little bit of idea of like the numerics of it. Like, for example, finding min values and max values. And then of course, an easy one to do is df.head just to make sure we have, oops, not cheat, head, just to see like a little bit like what's in here. Okay. So I would say like these three commands, df.head, df.describe, df.info, like almost every time. I'm almost like in a sense, like I would just like write those out of this muscle memory just because that's what I do. Cool. All right. And then Eric just wanted to clarify, just so I got this right, the and keyword is a truthiness comparison and is the bitwise comparison. Yeah, just to re-emphasize that. Cool. All right. So we are about at time right now. Are there any questions at all of anything we talked about today? Mm-hmm. Cool. All right. Just a reminder is that next week we will talk about topic 5, which will start using Pandas to basically start exploring and manipulate explore the data and basically fill in, manipulate the parts where if you're having missing values. So exploring to find the missing values, and then what do you do with those missing values, and kind of using the data frame itself. So make sure before next Tuesday, I would say at the very least, skim through that section. Even better if you can actually get through that section, topic 5, before our study group next week.